Gary's question was, can you store programs in there? And I kind of gave a yes, right? So the problem is you have to load, in order to do that, you would have to load the program out of the SD card and put it into RAM and run it out of RAM. That is not a trivial thing to do. There's an operating system out there called RetroBSD that runs on a Fubarino SD, and it is a BSD Unix operating system for a PIC32 that runs off of SD, and all your programs are stored off of SD, and it loads them and runs them. The shortest path to doing that would be to use RetroBSD. If you didn't use RetroBSD, you need to really dig in and do a lot of sophisticated programming. My guess is, with my experience, I could probably get it to work with about 2 weeks worth of effort, full time. Right? So that's what I mean by it's non-trivial, right? A lot of programming experience and a little bit of effort to make it work. The good news is other people have already done the hard work for you if that's what you want to do. What was your question?
What does that do again?
What?
What is it that you do again? I'm sorry.
Gary's question was, can you run a program off the SD?
Oh, okay. My question was, I noticed that in some computers, laptops, when you plug in your USB device, sometimes it tells you that it can be used as a memory.
Yes.
How does that work?
Okay.
So not to store stuff, but to speed up your computer. That's RAM.
Okay, so that's completely different from this topic. But I'll diverge briefly, right? What Microsoft is doing, like Microsoft, you can put an SD card in, they'll say, well, we can speed up the computer. And so what they're doing is, when the operating system loads, you have all this memory, right? A big chunk of this is going to be operating system functions. It's just function calls that the operating system uses to do whatever it needs to do. What Microsoft will do is they could write all this stuff that's in RAM out to the SD card, and when the computer boots, they can read it out of the flash drive fast, maybe faster than off the hard drive, and restore and get programs to start up and run a lot faster. So they're kind of doing some tricks. Modern operating systems work is what they do. You have, let's say you have 4 gigs of RAM. You have 4 gigs of RAM. You want to run 100 programs, which is not unfeasible. Those 100 programs take 20 gigs of RAM. But you don't have 20 gigs. But it's no problem. What they do is there's a file on the hard drive that's called a page file. And this page file may be 100 gigs. And what they do is you load these programs up. Maybe this is one program, but only it's sitting in a loop somewhere, right? So only this chunk is being used, right? Now you need to load your second program. The second program needs this much memory, right? But what happens is you're out of memory. But what the operating system can do is it could go, well, look, we haven't accessed all this stuff for a long time, so we write it out to this page file, we save it, and then we blow this away so your program no longer has access to this. And we load in the next program here, or whatever we need of the next program. And so only the part of the program that's running is being accessed in this memory. The parts that aren't being accessed are written out to this page file. This is why adding more RAM to like a Windows or Linux or a Mac computer can speed it up tremendously. Because what happens is this swapping happens less often. And when the swapping happens less often, your computer seems to run faster. I mean, it does run faster. Programs run faster. Because RAM is very fast. I didn't mention, I often talk about, if you look at the design of a modern computer, everything in the computer, it's designed that way due to economics. Right? So you have your CPU, and inside the CPU, there's what's called cache, which is really fast RAM, or it's called static RAM, cache RAM or static RAM, built out of transistors. And it's expensive. Usually there's 1 to 4 megabytes of this. Not a whole lot in terms of modern computers. Then you have this RAM, this 4 gig of RAM, your DIMMs, right? This RAM is dynamic RAM. And dynamic RAM is built out of capacitors. And the way it works is you either charge or discharge the cap. And the problem is if you charge that cap, over time it drains. So dynamic RAM is slower than static RAM. Static RAM is like, flip-flops, right? It's transistors, flip-flops, super fast. Caps, they're discharging. So every once in a while, there's a dynamic RAM controller that has to go out, read that RAM, and refresh it. So it's dying, it reads it, and it will write it back to 1, right, to make sure it doesn't die. If it's a 0, no problem, right, because it's already dead. Right, so there's these little caps. A lot less expensive to build capacitors than transistors. Dynamic RAM is cheaper than static RAM. Comparably, you have 10 times as much, right? 4 megs here, 4 gigs there. 10 times, 1,000 times. Right? 1,000 times as much RAM. There's hard drives. Hard disk drive, right? Which, typically these days, no problem, 1 terabyte. 1 to 2 terabytes. A couple $100. No problem. 4 gigs of RAM, couple $100. 1 to 2 terabytes, couple $100. Ideally, and then, beyond this, right, kind of where we're going now is the solid state disks or like SD cards, right? But way more expensive than this, right? And this is this is greater than this, right? Ideally, it would be great, if we could just have everything this, but it would just make your computer super expensive. I guess the solid state might be somewhere in between dynamic and this, right? It's definitely more expensive than these mechanical drives.